Okay, so this was on 9-2. We learned how to write the equations using the words. Okay, so basically just working backwards. So here we have absolute value. So we have to make sure that our function is an absolute value function when we write it. I'm gonna skip a couple examples because I think that we should be pretty good at this. So doing number 1, we always want to write y equals, okay? Otherwise it means nothing. If we reflect, we have to make our function negative. It compresses 1/4, so that 1/4 is our a. Okay, so that goes in front, and then we have our function of absolute value. It moves to the right 6, so we have x minus 6 because h is opposite. And we move up 1, so we have up 1 on the end. Okay, using the form, now we have a quadratic. Okay, so let's do number 5. We have y equals, it is compressed 1/2, so that 1/2 goes in front. 1/2 is our a. Then we have parentheses because we have a quadratic. X, it moves to the right 5, so opposite of moving to the right is subtraction. Squared, I think that this is the biggest thing that you guys are going to forget, is going to be to write that squared and with the cubic. We have that little 2 up there, okay? So don't forget that. We can't forget our function. And we move down 3. Okay, with the general form of a cubic, we have y equals blah, blah, blah cubed now. Okay, so same thing. Let's do number 8. So we have y equals, it's reflected, so we have a negative. It's shifted left 2, so we don't have any a, no a, because there's no stretch or compress. Okay, so we just have that negative in front of our parentheses. It moves to the left 2, so opposite, don't forget that cubed, and up 6. Okay, now with a square root, let's do number 9. We have y equals, it compresses 1/2, so that goes in the front. Okay, then we have our function, and it shifts to the right 5, so we have x minus 5 all under our square root, and then on the outside we have down 3. Okay, finding x-intercepts, we want to set y equal to 0 and solve for x. Okay, so it's the same situation as solving for y-intercepts. We can have 1, 2, or none x-intercepts. We can have none or 1 y-intercepts. Okay, so for x-intercepts we can have 2. So for this example right here, we want to set y equal to 0, so we have 0 equals everything else. We want to subtract this 18 over to the other side. We want to get x by itself. Okay, so we have negative 18 equals negative 2, dot, dot, dot. Okay, we want to divide by negative 2 to get rid of this. So we'll have positive 9 equal to x minus 1 squared. We want to take the square root to cancel our squared. Okay, so what we do to one side, we have to do to the other. The square root of a number is plus and minus that number, so in this case 3. So we have 2 instances here. We have positive 3 equal to x minus 1, and we have negative 3 equal to x minus 1. Okay, so add 1 over, we get 4 equals x. Add 1 over, we get negative 2 equals x. So our ordered pair is 4 comma 0 and negative 2 comma 0. Okay, this is for number 1. I don't know why that was so blurry, but I just refocused it. All right, and that makes sense because we move up 18 units, right? And we have a quadratic and it's reflected. So that graph is going to look like this. Okay, so we have the vertex at 18 and our quadratic is going down because it's reflected. So we have 2 places where our function crosses our x-intercept. So we have 2 x-ints. Okay, so that makes sense. All right, I'm going to skip number 2 and do number 3. So we set y equal to 0. We have negative 3 square root x plus 4 minus 3. Add 3 over. So we have 3 equals negative 3 square root x plus 4. Okay, we need to divide this, okay, not add it. These are being multiplied. So we're going to divide by negative 3 on both sides to get rid of that. So we have negative 1 equals square root of x plus 4. We're going to square this to get rid of our square root there. Negative 1 times negative 1, or negative 1 squared, is 1, equal to x plus 4. Subtract 4, and we get x equals negative 3. So our x-intercept is negative 3 comma 0.